Welcome to the ztC Edge Automated Local Site Recovery Overview Training Module. Stratus's ztC Edge Automated Local Site Recovery, also known as ALSR, extends the protection of your business from localized power failures and building-wide problems to physical machines located in different buildings or data centers. With ALSR, if disaster strikes in one location, applications and data are immediately available, up to date, and fully operational at the other location without the need for IT staff at the second location. An automated local site recovery configuration connects two physical machines in two geographically separate sites. ALSR provides application availability using synchronous replication and is a disaster-tolerant deployment that maintains hardware redundancy. And with ALSR, Stratus strongly recommends the use of the Quorum service on servers whenever ALSR is implemented. Quorum servers provide data integrity assurances and automatic restart capabilities for specific failures in a ztC Edge environment. If you're planning on implementing ALSR without Quorum, please review Knowledge Base Article 9682, Considerations if Deploying Automated Local Site Recovery Without Quorum, which can be found on the Stratus Self-Service web portal at support.stratus.com. In a non-ALSR configuration, there are two ztC Edge nodes. Here we see two ztC Edge 110i systems. Please note that the same configuration rules apply to the ztC Edge 100i systems as well. Communication between the nodes occurs over two networks. The A-Link network, which is directly connected from Node 0's A1 port to Node 1's A1 port, and the private/A-Link network, which directly connects to Node 0's A2 port to Node 1's A2 port. Please note that the A1 and A2 network ports are located in the rear of the ztC Edge 110i system. External communication occurs over the business networks. The P1 port is a required connection and is named the Business/Management port. This port provides access into the ztC console and connects to a switch. All other business ports are optional ports that can be utilized for VM traffic. The optional business ports are labeled P2 through P6 and are located on the front of the ztC Edge 110i system, and each port connects to a switch for external communications. Please note that the ztC 100i system has all of its network ports in the rear of the system and has only two business ports, P1 and P2. Typically, a site will be considered an ALSR configuration when the length of the direct connect cables connecting the two nodes is greater than 10 meters, for example, in two separate buildings within a campus. Or the two nodes of the system are connected using network infrastructure rather than direct connect cables. Here are some considerations when implementing ALSR. As mentioned previously, if the length of the A-Link direct connect cables connecting the two nodes is greater than 10 meters, the site is considered ALSR. Also, if the two nodes of the system are connected using network infrastructure rather than direct connect cables, the site is also considered ALSR. And when configuring an ALSR site, each A-Link must be connected on its own VLAN. A-Link traffic is not routable. An FTVM requires less than 2 milliseconds round-trip time, A-Link latency, and an HAVM requires less than 10 milliseconds round-trip time, A-Link latency. You'll need to provide enough bandwidth to meet the needs of all VMs on the system, and you'll need to provide a speed of at least 1 gigabit per second per A-Link. When planning your network infrastructure, you need to account for the uplink bandwidth between the switch and the network backbone across all the ports in use on that switch. Please note if these requirements are not met, guest VMs may run more slowly due to limited synchronization bandwidth between the two nodes. Now let's look at typical system behavior. A ztC Edge system is designed to provide high availability for one or more guest VMs, which allows the VMs to continue to run even during failures that otherwise create application downtime. The ztC Edge system can continue to run guest VMs even with, for example, the loss of a single network connection, a hard disk, or even an entire node. However, if more catastrophic faults occur, for example, a loss of all possible network paths, the ztC edge system attempts to determine the overall state of the entire system. The system then takes the actions necessary to protect the integrity of the guest VMs. In this ALSR example, the ztC edge system includes node 0, which is the primary node, and node 1, which is the secondary node, but this configuration does not include a quorum server. Operation is normal. No faults are currently detected. The two nodes communicate their state and availability over the A-Link connections, and the business management network is connected to a switch and functioning normally. This is how a system without any faults is expected to be configured and run. In this example, we'll assume the VM is running on node 0. Since it is the running VM, it is considered the active VM. Since the system is duplexed, meaning it is redundant, there is a standby instance of the VM running on node 1. A catastrophic event severs all business and A-Link network connections on node 0, while leaving power available and the system running. The VM instance on node 0 detects the loss of both A-Links as well as all other network paths. The VM instance can no longer detect the presence of its partner, but since it is the active VM, it continues to run. The application inside the guest VM continues to run, but perhaps in a limited capacity due to the loss of the networks. On node 1, the VM instance also detects the loss of both A-Links, but the business network remains available. As its partner does not respond to messages on the business network, the VM instance changes from standby to active and begins running the guest VM as it believes the VM instance on node 0 is down. Once both VMs become active, it places the system into what is known as split brain condition, where both VMs believe they are the active VM. In this instance, all synchronization and heartbeat connections between the active and standby VM is gone. Split brain creates data and availability inconsistencies originating from the maintenance of two separate data sets with overlapping scope. Split brain can lead to serious unrecoverable errors. If each VM considers itself as the active and commits any transactions that the other VM does not, then you cannot resynchronize the nodes because there is no way to merge the information on each node to create the correct information. Transactions committed on the wrong active VM during the dual active situation will be lost when synchronization is reestablished. After some time, the fault is fixed and the network connectivity is restored. When each VM of the VM pair realizes that its partner is back online, the VM with the fault handler rules chooses the VM that will continue as active. The choice is unpredictable and does not include any consideration for which VM's performance was more accurate during the split brain condition. The data that was generated from the now standby VM is overwritten by the resynchronization of the active VM, and thus the data on the now standby node is lost forever. After a split brain condition, the system requires several minutes to resynchronize, depending on how much disk activity needs to be sent to the standby VM. If several guest VMs are running with different active nodes, meaning one VM is running on the primary node while a different VM is running on the secondary node, synchronization traffic may occur in both directions. This completes the Stratus Automated Local Site Recovery training module. Thank you for viewing this module.